Okay, so today we're just doing linear inequalities, which is what we were doing last time, but with application, which just means I have real world in there. Okay, some of it's real world, some of it's just word problems, okay, but it's all the same. So we are going to look at some different inequalities and words that represent those inequalities. So we're going to start with greater than or equal to. Okay, a word that you could use when you mean greater than or equal to is also at least and no less than. Obviously there are others, but these are going to be the main ones that we focus on in here. Then we have less than or equal to. Okay, which can also be at most. No more than. And also if we talk about a budget. Y'all, if you talk about a budget, do you want to spend more than your budget? No. Is it okay to spend less than your budget? Yeah. So that's why it's less than or equal to. Okay, we're not going to really talk about too many different ways. This is just less than, and this is just greater than. Okay, so the first one, it says 12 subtracted from, what does from tell me to do? Switch, okay, so that means that 12 is going to go second, and 3 times the number. Do we know what number? So that's 3x and 12. So how are we going to write that if it says switch? (3x minus 12), you're exactly right. Is less than 21. How am I going to solve that? Add 12 first. That cancels out, and I'm left with 3x is less than, that gives me 33. Now what? Divide by 3. And I get x is less than 11. Okay, so if less than goes which way, left or right? Left. And is it going to be a parentheses or a bracket? Okay, and then this whole thing is part of my solution, so all of this is shaded. So it goes to the left forever, which is negative infinity to 11. Now, is 11 part of your solution? Is 11 a solution? No. Because is 11 less than 11? No, and we used a parentheses, which means 11 is not included. However, is 10.9 included? Is 10.9 less than 11? Yeah, so that would work. Okay, so remember, it's only things that are less than 11, not including 11. Okay? So I want y'all to try number 2 while I take attendance. It's a lot like number 1. Okay, what's going to go first? 35. So yes, it says twice a number subtracted from 35, but the word from tells me to switch or flip it. So we're actually going to write 35 minus 2x. Don't forget that. Is greater than 15. And now what? Minus 35. And I get negative 2x is greater than negative 20. Now what? Divide by negative 2. And what did I just divide by? So what do I have to do? Flip my symbol. Okay, so I end up with x is less than positive 10 because 2 negatives makes it positive. So again, we have negative infinity, positive infinity, and 10, and it's going to look a lot like the top one because it's less than and it's not equal to. Any questions with that? Okay, the next one says Marie Chase and Jonathan Edwards are having their wedding reception at the Gallery Reception Hall. They may spend at most $2,000. So if I look at the top, at most is my less than or equal to. Okay, so I'm going to do less than or equal to 2,000. If the reception hall charges a $100 cleanup fee plus $36 per person, find the greatest number of people that can invite and still stay within their budget. Okay, which one's going to get the X, the 100 or the 36? 36. How do we know? Because the word per. Also, we don't know how many people, right? Isn't that what we're trying to find out? So my per person, I don't know how many persons, people. So we put an X. So it's going to be 100. And do you pay more than one cleaning fee? No, you only pay a cleaning fee once. So 100 plus 36 per person, so X. And how do we solve that? Subtract 100. Somebody else is going to tell me the next step. Somebody else. Huh? Divide by 36. Good job. And we're going to see what that gives us. So 1900 divided by 36 gives me 52.7. So I have x is less than or equal to 52.7 repeating. Now we don't have to do our number line here because it asked us a question. It said find, or told us to do something. It says find the greatest number of people that they can invite and stay within their budget. Well, x has to be less than or equal to 52.7. Can you invite 52.7 people? So what's the biggest number of people they can invite? Not 53, because that's not less than 52.7. Can you invite 52.6 people? 52, because there is no such thing as 0.7 people. Well, I was about to type point. Dang it. People. It's 52 people. Does that make sense? Okay, if it asked us for all of our options, we would have done the number line and this. But it didn't. It asked us just for the biggest option. Yes? Does that make sense? Okay. So one more. It says, Kasanga is eager to begin his education at his local community college. He has budgeted for $1,500. Well, right away it says budget. If that's your budget, can you spend more than that? No, so that's why we use the less than or equal to 1,500 for college this semester. His local college charges a $300 matriculation fee. I don't even know what that is, y'all. But a fee, just like here, a cleaning fee. Fees only happen once. And cost an average of $375 for tuition fees and books for each 3-credit course. A 3-credit course is like a 3-hour course, which is just one class. So don't let that throw you off because it said 3-credit course. When you get to college, most classes are 3 hours long, which means in 1 week you spend 3 hours in that classroom. So it's not in one day, unless you only go once a week. But anyway, so we have plus the $375 per class, or each class. So remember, each, every, and per tells me where to put my X. And this one had an each. So how do we solve this? I get 375x is less than or equal to $1,200. No, I was about to say dollars. I mean, yeah, it is dollars. Last step. Somebody new. Divide by 375. And this gives me x is less than or equal to, look, I already have it up there, 3.2. Well, can you take 3.2 classes? No. So what's the most classes he can take? 3. Okay, so flip to the back. Your practice is only 5 questions long. I am going to help you set up 2 of them because they're a little different. Okay, so look at number 2. It says Ben Holiday bowled 146 and a 201 in his first 2 games. Those were his scores. What must he bowl? Well, we don't know. That's why we're asking. So that's going to be our X. In his 3rd game to have an average of at least 180. Well, let's figure out where at least is. At least is right here with our greater than or equal to. So I know greater than or equal to 180. Because if you have at least, this is your smallest number. And remember, the mouth eats what's bigger. Right? Okay, so knowing that, how do you find an average? Because we want to average out his 3 scores, and we want them to be bigger or equal to 180. Right? You will, but what do you have to do before you divide? Don't you have to add them all together? So this is his first score, plus this is his second score, plus we didn't know his third score. That's what we're trying to figure out. So what do we put? X. So when you're finding an average, you add them all together and you divide by however many there are. Well, how many scores are we dividing? Or adding? 3, so we're going to divide by 3. This is how you're going to solve this one. Now, first things first, you have to get rid of the division. How do you do that? By 3. So if I multiply this side by 3, and I have to multiply this side by 3 because that's what keeps it equal, yes? So what I want to show you, this is what a lot of people keep making mistakes on. I'm not going to actually multiply this 3 in because I want it to cancel this guy. And if it does that, then it's gone, and I can't multiply it in. So does the top change at all? Okay, be very careful with that, yes? Okay, that's as far as I'm going with y'all on that one. Now look at number 5. Twice a number increased by 1. What do y'all think that looks like? 2x, twice a number, 2x, increased by 1 plus 1, is between negative 5 and 7. Well, let's put it in between those two. So negative 5 and 7. Now, because I put at least to greatest, the best part is you're just going to use less than. Less than. If it's between, you're going to put it between. Now, if it's between those two numbers, is it going to be equal to those two numbers? No, so I'm not going to put the underlines on my symbols. So this is what you're solving. Remember, this is an and problem. So where is your solution whenever you draw your number line? Where they overlap, where they cross each other. Okay? So those are the two things. And then one more thing is this number, 150 pound and 4 miles per hour, does not go in your equation for number 4. Okay, there's only 5 problems. If you finish and you've already finished Friday's practice, then you're done for the day.